Okay, I'm telling you. Now, there are some things we need to know because when we read a drawing, it becomes relevant. Now, for example, I've worked in Matin and 30, for instance. I've worked with ABB, Hyundai, and Heiko, so I've worked with more than one type. Surely I don't remember all the types in my head, and if I go to another station and find Schneider, I've worked with Mitsubishi once before. So, of course, I won't remember in my head what the schematic drawing looks like, but knowing how to read the drawing is what's important. If you know how to read the drawing, it doesn't matter if it's protection in G, catastrophic commissioning, or cooperation maintenance. Always have the mindset that you want to know the know-how, not just how this thing is done. If you understand this, take it as advice from me, whether in relays, GIS, or anywhere else. If you want to know this, learn how to understand it, how to get the keys to this thing, and don't worry if someone later explains the details to you. Once you know the basics that I'm going to tell you, you can apply them to any schematic diagram without any problem. And by the way, even after you finish the course, if you want to contact me on WhatsApp, you have no problem. Send me any question you have on WhatsApp, but please just the questions. We support it with images, meaning that young people come and say, boss, once I try to disconnect, it doesn't disconnect. Give me even a picture of the control start and tell me what type of GIS you have. Give me some details, some inputs so I can solve it, you know, because I'm explaining GIS. So I can be, anyway, you understand what I mean. Okay, the important thing now is that I have some keywords here that I identify with respect to the schematic diagram. Let's take a look at them together. I've written them down for you here, but I would like to go to the schematic diagram and have you see it with me. Any schematic diagram, including the one I sent you, is available in your Dropbox. You will find a PDF that contains the drawing. You have a page with the drawing in this format. This is the first page. I gave you an example, and I brought you another example, 13.8 from 10 kilovolts. This is a switchgear, actually. Okay, I want to know what it is. Look, the first thing you look at here, you will find this part below that tells you the manufacturer or vendor name. This drawing belongs to whom? Who is its manufacturer? Is it Hidar, ABB, Alstom, Siemens? Who is its manufacturer? So this is one of the keywords. The other keywords are who your end client is. Where is your end client? For example, I have here the electricity transmission company, which is the Saudi electricity transmission company. Then I have the version of the drawing, not the version, let's say the edition of this drawing. Which edition is it? You have something called pre-commissioning, and you have commissioning, and you have the mock-up, and you have the as-built. The pre-commissioning is always the first phase. If you come to the pre-commissioning, you start by deciding the flow or ensuring that your drawing is the required drawing or not. After that, once you start and find defects, find missing parts, or find things that are not correct, you fix them. You make adjustments to the drawing and go to the designer, who then sends you the finalized version. You are supposed to have your cell, your actual drawing, where it is located. In your panel, during the commissioning phase, the operations and maintenance people come to you saying, I want this, adjust that part, add this, we need to add a set of components to this section. And so on. You start making a markup, which means erasing things, adding things, drawing specific shapes. You create a markup drawing, which includes the modifications and required items marked in red and green pen, with some items required in green and others done in. Once the station is operational, you take your drawing and give it to the designer. The designer then incorporates the final modifications as the station is now energized and operating with these changes. They draw it up and send you the as-built drawing, which reflects how it is currently built and how the station is operating. This is the final version you have at your station. All right, great. This is what we refer to as the as-built. You need to know which drawing you are working with, because if the station wasn't completed and you bring me a pre-commissioning drawing, or for example, a commissioning drawing, there might have been modifications made afterward. You need to provide me with the as-built, because you might see something and start looking for the existing axes in front of you, but you don't find them in the drawing, or you might find in a drawing that the axes aren't present in front of you on the panel. So you start troubleshooting or doing something that doesn't match. This wire went from this place to that place, but it was modified with something added in between. Yet the drawing doesn't say that, or the situation doesn't reflect that. So you need to be aware of which version of the drawing you are holding. All right? Then we have a very important part here. This part describes the description of the description of your drawing, exactly. The description of your drawing. Follow the description, meaning it tells you that this is the optimized scheme diagram for the capacitor bank, cell number 801. Okay, your feeder is 13.8 kV. This is its quality. Capacitor bank feeder. This station is the construction of new Mubarakia. Okay, this is the name of the station. Its voltage level is 132 at 13.8 kV space station. This is the new Al Mubarakia. That's the name of the station. The station's voltage level is 132 to 13.8 kV substation. You follow this, and this is what it tells you. What it tells you is nice or excellent. You don't have any specific problem. So I understood the description here. Then you find here you have the drawing number. Here, your drawing number is very important. Why? Because the interface between the cells is done by referencing the item you are using from other cells with the drawing number or the drawing number of these other cells. So this drawing number is among the very important things that you see. So you know whether I am holding the correct or incorrect drawing. You will find in the section after that. Then you have the last part, which is, or not the last, I mean the sheet number, which is the last part in the drawing, meaning the sheet number, how many pages it has, its revision, this is the complete version. Okay, so here, everything we studied before is data about who the manufacturer is, the vendor, etc. Who is your end client? Is the drawing version pre-commissioning, markup, or as-built? What is your project about? Or what is the description of this cell? What is the drawing number, the sheet number, the page number you are on, and the total number of sheets, everything, and division. All right, great. All right, and then here you have something we call cross-reference, which is one of the most important things you have. What is cross-reference? Your drawing is divided into something called the grid. Exactly, your grid is like what you see, A, B, C, D, E, F, and so on. It's like if I drew it for you in another way, for example, you have the A going this way, all right, and then you have the B going this way. Then, for example, the C goes this way. What is this? It's a collection of rows, then the D, and so on. Above, you have a collection of columns, one, then another column, number two, a third column, number three, a fourth column, number four, and so on. So in the end, what is it? It's a grid, all right? The purpose of this grid is to allow you to navigate to the number of the item, as we will see later in our drawing. Inside the drawing, you might find something that tells you it is located on a certain page in a specific place. What does in a specific place mean? Come here. If I'm standing right in front of you, I am a Muslim to tell you that this is originally a Muslim. It is on the page. I don't know what number is 13. So if you look at page 13, you open that page, you come to look at this page. Where is this thing? Related? I have a lot of things here. So here I give you something called a cross-reference. What is this cross-reference? As you can see here, it is a combination of a letter and a number. The letter describes which row you are in, and the number indicates which column you are in. Inside the page, so you can quickly navigate to something like this. All right. Okay. If I hold the main drawing here like this, I will come here to the first page, which was this page. What is the first page? The page in front of you. So of course you can come down here to see who the vendor is. The same thing here. Here is the vendor, or who is your vendor? It is Hyundai, which is Hyundai. And you can come here on the right to see who your end client is, the Saudi electricity company. And you can come down here to see the project name 115 kVGI schematic. This is about the construction of Kafji or Kafji station 380 to 115 to 138 BSP for bulk supply coin, which refers to 380 kV stations, 8800 and 15 to 13 and 8. This refers to the Turkish stations 80 kV, right? Add drawing number here and add sheet number and the total number of sheets and add our revision, all right? And as you can see here as well, cross, all right? But then you'll come here and tell me, well, what's on this page? This page contains contents. What does contents mean? It means if you look here, you'll find a table. This table tells you the page number. And the revision of page D and the description, meaning page number 1. And this is a page that contains the contents. Page number 2 is the legend of symbols. Page number 3 is the outline. and so on. What's the purpose of this? The purpose, my friend, is that when you are a maintenance engineer and you work in more than one station and you don't know all the schematic diagrams, you are now going because there is a problem in Ipo. If your eyes are accustomed to that, then you know the general shape, but you are not used to it normally. Come here, sit down, let's walk. Look for where the circuit breaker is located, where page 10 and 10A are. Okay, you see the page here? Keep going like this until you reach page 10. Okay, this is the closing. Make sure it's our closing. Look at the side. What is it? Here it is, 6111 closed control circuit. So you make sure this is the page in the table of contents. This allows you to navigate to a specific page quickly, which helps you in the troubleshooting process. Quickly, nothing more, nothing less. You reach each page, which is about what? Okay, the second page, as you can see, is what we call the legend of symbols. What is this legend of symbols? It tells you the symbols that are used in your drawing. What is the shape of the abzur? What is the shape of the timer? What does your lamp look like? If you have a Hiba heater, what does it look like? Types of contacts, early make, late make, early break, late break, current, transformer shape, voltage transformer shape, motor shape, the appearance of the current transformer, the voltage transformer, and the motor. The shape of the spring, all the symbols that the item uses within the drawing are present on this page. Of course, this page is labeled below here as legend of symbols, right? Based on the table of contents, meaning that legend of symbols I saw is the table of contents, right? Okay, it also gives you some additional things, which are what? It gives you a description of how it writes inside about the obsolescence, meaning what it means. It tells you now you have the first part. The first part is not forgotten, which is the legend of symbols, right? The second part is something called detail of control switches. It tells you how it explains any control switch you have inside. Any switch that we will see later inside the options is specified. It comes and tells you what the switch is. It writes S and gives it a number. Okay, and underneath it is drawn a set of contacts, and the symbol for it is drawn. The contacts come like this, and there is a set of contacts. 1 and 2 are normally open, 3 and 4 are normally closed, 5 and 6 are normally open, 7 and 8 are normally closed. That's the switch. Select all switch. I said I connected it with a switch. Then it tells you that 1 and 2 are on, meaning it creates a node that is black when you have this switch in the on position. When you switch to the on position, contact 1 and 2 become closed or change position, and 5 and 6 become closed as well. However, 3 and 4 and 7 and 8 do not change their position. When you turn it off, 3 and 4 change their position, and 7 and 8 change their position. You are now in dual open position. Others are dual closed. All right, these remain open as they are, and those are closed. When you switch to the on position, 1 and 5 become closed, 1, 2, 5, and 6 become closed, and 3, 4, 7, and 8 become open. Is that clear, engineer? So 1, 2, 5, and 6 change their position to closed with the on position, and when do 3, 4, 7, and 8 have their status as closed in the off position? All right, so the black nodes mean the status of these contacts is drawn like this in front of you, indicating their position. It tells you that 3 and 4 are closed in the position you see in front of you in the off position. Is that clear? 1 and 2, then 1, 2, 5, and 6 are in the open position. All right, when do they change their position in the on position? 1 and 2 close, and 5 and 6 what? 5 and 6 close. All right, nice. Very good. Of course, 3, 4, 7, and 8 open, depending on what we will see. Inside, we will encounter many of them. So we will see inside how it actually looks. Is that clear? Nice. Okay. Here, it might tell you, for example, you have a contactor or a button. Then it might tell you here you have another component. It tells you K1, K2, K3, and so on. And here, this component tells you which page it is on, which is the page. This means the first number is the page number. .10 is on this page. All right. And here you have these two terminals. It tells you these are the coil terminals. Their numbers are such and such. Then what about the contacts? The contacts for this are here. Terminals 1, 2, 3 are written as 13, 14, 15. Here is the name of this contact. It belongs to the auxiliary contactor whose coil is named K1, and this is its cross-reference again. So the auxiliary contactor is essentially what, or what is the contactor? It's a coil along with a set of contacts, right? The coil is drawn in a square shape like this, and its terminals have their numbers written on them, and next to it, the contactor number is written as K1. And below it, the cross-reference is written, indicating where its source or details can be found, such as on page 23 with the number 10. The contact associated with this contactor or auxiliary is drawn as you see it. Open, close, change over, and it has its terminal numbers. Next to it, the same number of the contactor or auxiliary is written, along with its cross-reference or location, indicating which page B it is on. And its cross-reference means D6. Who is the cross-reference of this contact? It means it tells you that this contact comes from the contactor named K1, and its coil is located on page 8D6. What is this contact related to? The relay parts named K1, its coil is located on page 8D6. You might say, how? This contactor is written on page 23. No, its details, meaning what is it used for? It is on page 23.10, and we will see this. Listen to me the first time, and I will repeat it once so it sticks in your mind, okay? Just like here, it's the same thing, right? Also what? Another contactor. How will I become a kibash and forget? The drawing principle is nice because it tells you that anytime you have. He wants to tell you here that if you come to tell me, for example, that the 125 foot or anything draws an arrow like this going to a certain page, he tells you it's going to page 8. Where on page 8, it's going to column number 1. If it's coming from somewhere, it draws the arrow from behind, and then a line tells you it's coming from page 8. Or also, don't worry, it doesn't mean I won't tell you. As we move inside the drawing, every time I won't repeat all the talk. All right, okay, this part concerns me. I wonder when he finds things like this inside the drawing, just look at it like this. All right, things are drawn normally like this, and things are drawn inside a contradictory box like this. What does this box text mean? He said, look, this means the following. You have boxes here, all of which are dashed. If the box is dashed and inside a black square, it means a mechanism box, meaning a mechanism related to a breaker mechanism or a switch or ground. So this is the control box for the switch, ground, or breaker present in the device. Also, great, I am now inside a control panel. So anything, meaning I am inside the control panel. This control panel contains an auxiliary relay, a contact, whatever it may be. But this contact is a wire going to another place, meaning this wire brings me the status from the breaker. Listen to me, I will say this tomorrow at the beginning of the lecture, but I always throw in some information knowing that your mind is now saturated. But tomorrow, God willing, when you hear it for the second time, you will understand it better. But listen to me, I am now throwing information at you, not like I took a pen and paper and explained it to you in detail. So what he is telling you is that inside the drawings, for example, like the diagram I showed you, here it is. All right, inside the drawing here, it might be drawn with a set of keys. As you can see, these are all things present inside where I am. However, when something is done with a dotted line, it means that the things inside it are coming from another place. So, what is this other place? Well, it is drawn, meaning if it shows you a black box here, it means it's coming from a mechanism box of a breaker or a switch or a ground. If it's half black and half white, it means it's coming remotely, maybe from a substation automation system, and so on. If it's a black circle or sphere, it means it's coming from another control panel. All right, engineer, that's good. Let's explain this part. There's nothing to it. After that, if you look at this page in the description, it will tell you the outline arrangement, meaning how the cells are arranged. As you can see, the shape of the panel here. Okay, so what is the shape of this panel? Because someone might ask what panel shape you're talking about. Look, engineer, I'll send you a picture on WhatsApp. I want all of you to look at it now. All right, let's also have another picture. I've also sent you another picture just now. Here it is. First, take a look at the first picture I sent you. Did I send it to the same place or what? Oh, okay. Well, here it is. All right, the first picture. Just don't forget the one I sent you, the one with the JS. You'll see it as you look. Okay, here it is. You have it here. This is the JS itself, okay? It's written here for you. This is JS. All right, it's written for you like this. This is the JS itself. As we saw in our video, it's in the breakers, in the switches, in the current transformers, in everything. And opposite it, there's a set of cells, which I also showed you in the other picture. All right, these cells contain the control circuits that control the mechanism itself of the breaker or the disconnector switch or the air switch present in the JS. So I have two parts now. The LCC panel, which contains the control circuit, and it has the drawing that I will explain now. And the other part is the JS, which contains the mechanism of the breaker, including the motors of the breaker, the spring of the breaker, the motor of the disconnector, and the air switch, the current and voltage transformer. It contains the primary components themselves that open and close, and their control circuits are located in the LCC panel, which is the local control cabinet that I am now explaining. I'm explaining our schematic diagram. So here we have drawn the shape of the panel. The panel consists of two doors. Here is the door, and it has something like a single line diagram that I have drawn for you. Here, there is something. So what does the cell look like from the side? If I open the cell, for example, here is the first door and here is the second door. Now, if you open the second door, you might find in front of you a set of MCCBs and others. So what does the whole view look like at the beginning and the end? What is the first? I don't check this, but at the very beginning of the station, just to confirm that the structure has been delivered to me at the station. But what is it? What is the address? What is the address of the opening?